This beach behind me is well known in the local area for having fossilised shark's teeth, tens of millions of years old. People come down here with their kids, they go through the beach and they find them. As an astrophotographer, it's helpful to have a yardstick by which to measure how long it's taken photons from objects that we photograph in space to reach our camera sensors. Because the human mind, I find, tends to struggle with these immense numbers. For example, there are two sort of bandwidths that we shoot in terms of time scale when we're shooting deep sky objects. You have a nebula and then you have galaxies, which can be in the region of 30 million light years away. So there's an immense gap there. What I like about living in this area, however, is that all around me, there are things that can help me pin down these yardsticks, like the shark's teeth I just described to you. Or not far from me, there's a wheat field that was harvested last week. That's got some significance because around about 7,000 years ago, Paleolithic and Mesolithic nomads began to settle in Britain, importing with them farming techniques that they'd refined over the preceding 2,000 years to that in continental Europe. That time frame, as I said, is significant because that is about the amount of time that the photons from the object I'm going to show you today took to reach my sensor. So around the time those nomads were settling here, those photons departed their point of origin, traveling at the speed of light, and took up until yesterday to reach my sensor, where their journey terminated. So you might be asking yourself, what is this deep space object that he's talking about? It's called the Bubble Nebula, and it's about 7,000 light years away in the constellation Cassiopeia, a near perfectly formed sphere, blue and red in colour. Those colours derived from the gases that are being emitted from a nearby star with a mass 45 times the size of our sun and 1 million times brighter. Those gases are hydrogen and oxygen, two of the gases that emit a certain frequency of light that narrowband images capture. Just further up from here where I'm taking you now is a bunker. And it was inside that bunker about 4 months ago that I shot my first deep sky object. And through a crack in the concrete, I had an image of a portion of sky that I'd stacked. When I got it back, it was just a star field, and there was no deep sky object readily apparent to me. But I spent some time poring over the image to see if there was indeed anything there. And after a while, I found something. It was a bright green donut in the bottom right of the frame. That donut turned out to be M57, the Ring Nebula. It was at that point that I became fascinated with this hobby. To think that I could take a regular camera and photograph a nebula really spurred me on to want to do more. Let's go and I'll show you where that bunker is now. One of the things we need to be mindful of as astrophotographers is the sky conditions that we're shooting into. One of the most desirable things is a dark sky. Although you can image from cities and heavily light polluted urban areas with narrowband filters and still get good results, nothing beats a dark sky. One of the benefits of living next to the sea is that when you shoot that hemisphere of sky, it's largely devoid of light pollution, which is a great thing. This here is the North Sea, one of the busiest shipping lanes in the world. Where I live is a Border 4 class sky, rural skies. Not perfectly dark, like a pristine dark site, but still very good for astrophotography. However, there are trade-offs with everything. And when you're using a narrowband filter, you need to expose for longer in a dark sky area to overcome the read noise of your camera than you would in a heavily polluted urban area. One of the reasons that astrophotography becomes so complicated so quickly is in pursuit of those long sub-exposure lengths. The longer the sub-exposure length, the more accurately we need to guide that setup onto the field that we're trying to image. One of the ways we do that is with a separate guide camera and guide scope mounted to our main telescope. That guide camera's job is to pick a single star in the sky and use it to tell the mount which corrections to make in order to stay accurate to within sub-arc second tolerance. As the focal length grows and you attempt to use longer telescopes, your guiding needs to become more and more accurate in order to maintain long sub-exposure lengths with narrowband filters. And so we've arrived in the bunker where my astrophotography journey began 4 months ago, with that camera and tripod pointing up through this crack right here. And trust me, at 1 AM, it's a bit darker and dingier than this. With that, I welcome you to Astro Candy TV. Join me on this journey as I share my astrophotography adventures with you. Welcome to the channel.